Good morning, students. So we are in week 4. We'll be looking at series and sequence. Sequence refers to a series of numbers. When you have series of numbers separated by comma that follows a regular repeating pattern. Like for example, if you have 1, 3, 5, 7, 9, and so on. This is referred to as sequence. While series, similar to this, when the numbers also follows a repeating pattern, a regular repeating pattern, but separated by additional sign. So we refer to, this is the difference between series. This is a series, while this is a sequence. So this is the difference between series and what? And sequence. However, both of them normally follows a regular repeating pattern. So we have different types of sequence. Basically, you'll be dealing with two types of sequence. The first one we'll be looking at is what we call arithmetic sequence or progression, or we call it a linear sequence. Arithmetic progression, number 2 is the geometric sequence or progression. It can be geometric progression, and we can also call it exponential sequence. For today, we will be dealing with arithmetic progression. Which we can short, the short form is called AP. So when you see AP means arithmetic progression. So now we'll be looking at the end term of arithmetic progression. The end term of arithmetic progression can be represented what we call Tn, in which the general formula is A plus into bracket n minus 1d, where this A represents the first term. A means the first term in the sequence. N represents the number of terms. YD is the common difference. Note, this formula that represents the end term of an AP can also represent the last term, where L means the last term. What that means is that the last term can also be given as A plus into bracket n minus 1 times D. And also this also represents the end term of the sequence. Kindly note that this common difference, D, is the most important in arithmetic progression. This D, which is called the common difference, will tell you whether a sequence is AP or not AP. For example, let's assume we have a sequence 1, 4, 7, 10, 13, and so on. How will you know whether this sequence is AP or not? You can only know by finding what we call the common difference. Common difference means the difference between the numbers. That is, the second term minus the first term must be the same thing as the third term minus the second term, and also must be the same thing as the fourth term minus the third term, and so on. Once you experience this, what that means is that such a series or sequence is an AP. Like for example now, 4 minus 1 will give us 3. 7 minus 4 will also give you 3. 10 minus 7 will also give you 3. 13 minus 10 will also give you what? 3. Meaning that the number is increasing by a factor of 3. And one of the major advantage of a number obeying a regular pattern is the ability to find other numbers that is not being given. So meaning that from here now, from this formula, A represents the first term. The first term in this sequence is 1. The number of times you can determine that. YD, which is the common difference here is going to be 2. This is just the explanation of the nth term of an arithmetic progression. To explain this further, let's look at an example on this. Like for example, for each of the following AP, you are asked to find the common difference, the 9th term, the 21st term, and the nth term. And we have the AP to be 1, 4, 7, 10, 13. This is AP now. So let's find the common difference. The common difference is D. That means the second term minus the first term, which is also the same thing as the third term minus the second term. If we should do that from here, we can see that our common difference will be 4 minus 1, which will be the same thing as saying 7 minus 4, and all will still give us 3. It means the common difference is 3. Now, let's find the 9th term. The 9th term means T9. That means the 9th term. And using this formula, it means the n is 9. N is 9. By the time we substitute here, so we are going to have A plus bracket 9 minus 1 times D. This is our n now. Our n is 9. So 9 minus 1. So our 9th term will now be A plus 9 minus 1, that is 8 times D. That's not all. From this sequence, we know our A. Remember, A means the first term. So our first term here is 1. So you insert 1 here plus 8 times D. D is the common difference. And we know the common difference from the first question here to be 3. So we insert a 3, and that will give us 25. 8 times 3 is 24. 24 plus 1 is 25. So this gives us the 9th term. Question C says we should find the 21st term, which means A plus into bracket 21 minus 1 times D. That is, our n now is 21. Now we can go ahead. We know our A already from the sequence to be 1 plus 21 minus 1 is 20 times our D is already 3, and this gives us 61. That is 20 times 3 is 60. 60 plus 1 is 61. Now, the next is to find the nth term. The nth term. So let's find the nth term here. How can we find the nth term? That's the next question. That is D. This says we should find the nth term. Remember that the general formula still remains the same. A plus into bracket n minus 1D. The nth term will now be, our A is the first term, which has been given to be 1 from the sequence. So we are going to be having 1 plus the nth term, which is n minus 1. The D is 3. So we can then break this down. 1 plus, open the bracket, 3 times n will give us 3n minus 3 times 1 will give us 3. Collecting like terms, 1 minus 3 will give us minus 2. So we're going to be having 3n minus 2. So this represents the nth term. Therefore, the nth term of that sequence is 3n minus 2. So this is the nth term of the sequence. So this example has explained to us how to make use of the n-term formula of an arithmetic progression. So in our next class, we'll be looking at more examples on how to make use of the n-term of an arithmetic progression. Thank you.